So here's your problem. A Spartan is preparing for a battle by increasing his strength of throwing spears. He throws a 5 kilogram spear at a 50 kilogram block of wood hanging from a branch on a tree. What is the velocity of the spear when thrown if the block and the spear have a final velocity of 2 meters per second? How fast must the Spartan throw the spear to get the wood to end up swinging 3 meters higher than his starting position? So the first step is to draw a diagram, which I have done here. You can see I have my Spartan with his spear with a mass of 5 kilograms, and you can see you have the block of wood on the string, which has a mass of 50 kilograms. Here is the second part where the spear enters the wood, and it's traveling at a velocity of 2 meters per second. The velocity of the spear in the beginning, you are trying to figure out. And that's your diagram for the first part of the question. Second part of the question has a very similar diagram, except instead of focusing on the 2 meters per second, you focus on the fact that the block has swung up 3 meters from its starting position. This is the only equation you need for the first part of the question, which is momentum equals mass times velocity. The concept you need to use is the law of the conservation of momentum, which says that momentum has to be conserved. It cannot be created or destroyed. So this is the solution. Because this is a totally inelastic collision, you know that the momentum of the spear plus the momentum of the wood equals the momentum of the spear plus the wood. The law of the conservation of momentum also tells you that. So you use the momentum equation and plug in all your values and find out that the speed of the spear is the only unknown. So when you simplify, it's an easy equation that you could solve and find that the velocity of the spear is 22 meters per second. And that's the answer to the first question. Now the concepts that you need for the second question are again the law of the conservation of momentum and the law of the conservation of energy, which basically says that energy cannot be created or destroyed, similar to conservation of momentum. The equations you need are a little different though. You need that momentum equals mass times velocity again. You also need, that's new, kinetic energy equals 1/2 mass times velocity to the second power, or squared. You need gravitational potential energy, which is mass times the acceleration due to gravity times the height. So here's your solution. You first use the law of conservation of energy to justify how the kinetic energy that the spear has is equal to the potential energy gravitational that the spear and the block of wood have. So you use the equations that were on the previous slide and plug in your values for kinetic energy and potential energy gravitational and find that the speed is the only unknown value. When you simplify, you find that it's again another easy equation that you could solve for the speed. So you find that the velocity is 7.67 meters per second. This, however, is not your answer. This is the velocity of the spear plus the block of wood. So you have to use the law of conservation of momentum to again say that the momentum of the spear plus the momentum of the wood equals the momentum of the spear plus the wood. However, when you plug in your values, these three are the same, and also this one, but instead of 2 meters per second, you put in your 7.67 meters per second, which you calculated up here. Then you simplify it down and solve the easy equation that comes from this, since v is your only unknown. So when you solve it, you find that the velocity is 84.37 meters per second. So just to recap, the velocity of the spear when thrown the first time is 22 meters per second, and the velocity of the spear must be 84.37 meters per second the second time.